Okay, everyone, let's begin with this then. November 2020, paper 3, variant 1. We are going to be doing difficult questions from this paper and then from paper 3-2 as well. Now, in this particular session, for some reason, paper 3-1 and 3-3, they are the same. They might have been at exactly the same time on the same day. So they did not change the paper. So 3-1 and 3-3, they are both the same papers. So we will be doing 3-1 and 3-2. Okay, difficult questions from these two papers. That's the plan for today. Please have a look at the poll posted on the group. If you haven't already, let me know the questions that you find difficult from these from this paper as well. November 2020, paper 3, variant 1. Have a look at that if you haven't already, and let me know the questions that you find difficult. Okay, so I'll have a look at this myself as well and see if there's any question that looks relatively more difficult. So let's begin with this then. November 2020, paper 3-1 and 3-3. They're both the same, okay? All right. We have to solve this inequality. The first question, which is straightforward, modulus inequality. Then we've got this complex number problem. We've done many of these, so this should not be a problem now. dy over dx, you have to prove this. You just have to differentiate it and then use the double angle identity for sine and cos, and then it would eventually turn out to be cos theta over sine theta somehow. And then you can write that as cot theta. Should not be that difficult. Question number 4, again, a relatively simpler problem. You don't get logged with other bases very often. So in this case, the log base is 10. Mostly you get ln. So just know that it's just a different log with another base. Just like ln is log with base e, this is base 10 instead of log e, right? That's the only difference. You'll do it like you normally deal with log problems. It's just that at the end, when you have something like this, for instance, somewhere ln of x equals 5, how do you write that? You write that as x equals e raised to power 5. Here, if you have log with base 10 of x, this would be written as x equals 10 raised to power 5, because instead of e being the base here, the base is 10, right? That's the only difference. Everything else is exactly the same, okay? So it should not be a problem. It's not very difficult. You can try this. Question number 4, let's move on. Question number 5, no one has asked about this as well. So you have to sketch these graphs, use the table function in your calculator for this, all right, to get some points, then plot them, iteration. Then you have this trigonometry problem, cos and theta, that's you have a minus sign. You have to solve this equation. Instead of theta, you just have x over 3 here. Everything else is pretty straightforward. That does look like a very easy paper, actually. Verify this is a root of this equation from the other roots of this equation. Okay. All right. So since it's overall a relatively easier paper, what I'll do is I'll just do a few questions from this anyway. Let's look at this one. Again, not very difficult, just like average difficulty, but since some of you have asked about it, let's actually do it. Under root 6 cos theta plus 3 sine theta, you have to convert it to this form. So first of all, you see, if this is the standard form, you need to convert it to cos. You have minus inside, you have cos is the first term here, and you have plus here. So this is the standard form, and cos, the sign has to be opposite, and that is what the case is. And whatever is the first term here, it has to be converted to that form. And it is that standard case. All you have to do is, when you have a standard case like this, you can use use the formulas for A and for R and alpha. If you use that, you would say this is A. A is square root of 6. This is B, which is 3. R is going to be square root of A squared plus B squared. That's square root of 6 squared plus 3 squared. What does that give us? 6 plus 9, which is square root of 15. This is the value of R that we get. They wanted an exact value of R. You would not write decimals here. You would leave it in exact form. And then you have to find alpha. What's alpha going to be? Tan alpha is B over A. So that's 3 over under root 6. Put this on your calculator. Tan inverse of 3 under root 6. Make sure your calculator is in degrees mode, right? This is degrees. Let me change this. Tan inverse of 3 over under root of 6. What does that give us? That gives us 50.768. Now, the question requires you to give this answer correct to 2 decimal places. Since it's a requirement of the question, you have to make sure that you do that. Otherwise, you lose 1 mark. Okay? You lose 1 mark for that. So what do you get from this? 50.77, right? That's the angle that you get to 2 decimal places. Okay, let's move on to the second part of this. Now that you've got this, got the values of R and alpha, all you have to do is put them here. R is under root 15, and then you have cos of theta minus 50.77. That's the form that they wanted you to convert it to. Now let's move on. It says, hence solve this equation. Now, how is this equation relevant to the first part? In the first part, what we've done is we've proved that if you have under root of 6 into cos of theta plus 3 sine theta, that can be written as under root 15 cos of theta minus 50.77. This is what we have proved, what we have shown in the first part, that we can convert this expression to this form. Now, compare the two. What's the difference? Instead of theta, we have 1 over 3 times x. Otherwise, the rest of the expression is the same. So what's this equation now? This equation is under root 6 into cos of 1 over 3 times x plus 3 into sine of 1 over 3 times x. That equals 2.5. Now, this thing can be written in this form. You would say this is under root 15 into cos of, instead of theta here, you would just input 1 over 3 times x. So it becomes 1 over 3 times x minus 50.77 equals 2.5. And now you just have to solve this equation. You are given that x is supposed to be between 0 and 360. Let's solve this equation now. First of all, what you can do is you can use a substitution. Whatever is this inside here, you would say let a equals 1 over 3x minus 50.77. Since the interval for x was from 0 to 360, now what you do is you find the corresponding interval for a. What is the interval for a going to be? Input 0 in place of x here. What does that give you? That gives you minus 50.77. Input 360 in place of x here and see what that gives you. Let me try that. 360 divided by 3 minus 50.77, that's giving me 69.23. So the angle A is supposed to be within this interval. Okay? A is supposed to be inside this interval now. Now we write this equation like this. We say this is under root 15 into cos of A, that equals 2.5. Cos of A equals 2.5 over under root 15. Now you find the basic angle. How do you find the basic angle? You say cos alpha equals 2.5 over under root 15. Alpha represents the basic angle. This is already positive. Otherwise, you would make it positive first before you find the basic angle. Let's see what this turns out to be. Cos inverse of 2.5 divided by under root of 15. And that is giving me 49 49.797, or we can say 49.80. That's the basic angle that I'm getting. Now, if this is the basic angle, these are the quadrants. Cos is positive here. Where is cos positive? Cos is positive in the first quadrant and in the fourth quadrant, right? This is where cos is positive. So these are the quadrants that we're going to consider. Now, inside this interval, we consider one positive angle that is going to be here. So your alpha could actually be here or here. These are the two possibilities, right? Now, are both of these in the interval? Let's think about this. On the upper side, we have this angle as 49.80. So one possible value for A that we get is 49.80. That falls inside this interval. Now we can go all the way here, but that's going to be outside the interval. It's more than 69.23. So we can't consider that. However, since we also have negative values in the interval, we also have to go in the clockwise direction to see if there's any possible answer on the negative side as well. So in this case, if you go in the clockwise direction, you get this angle as well, which is minus 49.80. That also falls inside this interval. So that also needs to be considered. So another possible value of A that we get from this is minus 49.80. Now put that substitution back. You say 1 over 3x minus 50.77 equals 49.80. Or 1 over 3x minus 50.77 equals minus 49.80. If you do not adjust the interval, you would miss out on this answer. Okay, so that's very important. Most people in this question end up missing out this possible angle. Okay, so make sure that you don't do that. And that will only be possible when you adjust the interval correctly. Okay. Now you can find the value of x from this. What do you get from the first one? 50.77 plus 49.80 multiplied by 3. And that's giving me 301.7. That's one possible value of x that I'm getting. And then you have 50.77 minus 49.8 multiplied by 3. And that turns out to be 2.91 degrees. You can say that's 2.9 degrees. Generally, answers in decimals are supposed to be to minimum 1 decimal place. You can write more if you want, and that's okay. But if you were to round it off, it would be 2.9 degrees. These are the two possible values of x that are solutions to this equation. Okay, I hope that makes sense. That was question number 6 from this paper. The second part, a lot of people would do this error here that they would miss out in this possible answers. So make sure that you're not one of them. All right, good. So that's question number 6. Let's move on to the next one. It says verify that minus 1 plus under root 5 iota is a root of this equation, which is 2x cubed plus x squared plus 6x minus 18. Now, how do you do that? You have to input this value inside this equation, simplify everything and prove that the left-hand side and the right-hand side, they become equal. Now, how do you do that? This is the equation. This is 2x cubed plus x squared plus 6x minus 18 equals 0. What you have to do is you have to input x equals minus 1 plus under root 5 iota in this equation and see what that gives you. Okay. Now, for this, we would have to evaluate cube of this and also square of this, right? So what we can do is we can evaluate those two things first on the side. Okay, that will make things simpler. Let's do the square first. What is x squared going to be? Let me do that on the side. Minus 1 plus under root 5 whole squared. We would need to evaluate the square, right? So I'm doing that on the side, so we can use that then. Minus 1 plus under root 5 iota, what does this become? You can think of this as a plus b whole squared. That's a squared minus 1 whole squared, okay? Plus 2 into minus 1 into under root 5 plus under root 5 whole squared. Now let's simplify this. It becomes 1 minus 2 under root 5 plus, okay, I'm sorry, I missed out on iota there. I was looking for where iota is. finished writing that, under root 5 iota. That becomes under root 5 iota here plus under root 5 iota whole squared. Now, this question is very prone to errors, careless errors. Why? Because you have to evaluate the square, you have to evaluate the cube, and you have something in terms of iota. You do end up doing a lot of careless errors here, so you have to be very careful in your working. Do it relatively slowly so you're not making an error, because once you do make an error, it's very hard to spot it later on. Okay, so just slow down a little so you are not doing those careless errors. Okay, so minus 2 under root 5 iota plus 5 iota squared. Okay, so it becomes 1 minus 2 under root 5 iota plus 5 into minus 1. 1 minus 5, what does that give you? Minus 4. Minus 4 minus 2 under root 5 iota. This is the square of this number. Minus 1 plus under root 5 iota whole squared. All right, so we've evaluated the square. Now we evaluate the cube. Minus 1 plus under root 5 iota whole cube. What is that going to be? You can either use binomial expansion here if you want, or some of you might remember that formula directly, just like we have a plus b whole squared. That's a squared plus 2ab plus b squared. You can also remember this. Some of you, I'm sure, do know this already. A cubed plus 3a squared b plus 3ab squared plus b cubed. It comes from binomial expansion formula. You can remember this directly as well. That is very helpful. But in case you do not remember that, and you also do not want to use binomial expansion, the workaround is that you say, okay, this is a cube. You can break it down into two parts. You can say it's minus 1 plus under root 5 iota squared into minus 1 plus under root 5 iota. You can also do it like this, break it into two powers, 1 power 2 and 1 power 1. And now, since you've already evaluated the square, you can use that result. Okay, so you can say this is minus 4 minus 2 under root 5 iota whole multiplied by minus 1 plus under root 5 iota. And that is going to give you the cube. Minus 4 into minus 1, that is 4. Minus 4 into under root 5 iota, that's minus 4 under root 5 iota. Okay. And then minus 4 and minus 2 under root 5 iota into minus 1, that's plus 2 under root 5 iota. And then minus 2 into 5, which is 10 iota squared. This is what I'm getting from this. Do look out for any careless errors. It becomes 4 minus 2 under root 5 iota minus 10 into minus 1. And that becomes 14 minus 2 under root 5 iota. That's the result that you're getting here.
Sir?
Okay, yes.
Sir, how did you get minus 10 iota squared?
Put this on your calculator. 2 under root 5 into under root 5, that is 10. Under root 5 into under root 5, that will become 5. And then 5 into 2, that is 10. If you find that complicated, put this on your calculator. 2 into under root 5 into under root 5, your calculator should give you 10 for that.
Okay, sir.
Okay. All right. Okay, good. So we have evaluated the cube now as well. That's the cube. Now that we know what the cube term is and what the square is, now we can just input those here. We say when we input square and cube in this is going to become 2 into minus 1 plus under root 5 iota whole cube plus minus 1 plus under root 5 iota whole squared plus 6 into minus 1 plus under root 5 iota minus 18 equals 0. Now simplify everything. Instead of cube, you put this thing, the cube term. Take this on the side a little. Okay, so it becomes 2 into 14 minus 2 under root 5 iota plus, I've input this cube here, okay? Square term is minus 4 minus 2 under root 5 iota. And then outside, we've got 6 into minus 1, that's minus 6. 6 into under root 5 iota, that's 6 under root 5 iota minus 18 equals 0. It becomes 28 minus 4 under root 5 iota minus 4 minus 2 under root 5 iota minus 6 plus 6 under root 5 iota minus 18 equals 0. This is what we end up getting from all of this. Need to see if not. So you can see we have this constant term, these constant terms, they all cancel out. 28 minus 4 minus 6 minus 18, all of that becomes 0. Okay. And similarly, minus 4 under root 5 iota minus 2 under root 5 iota plus 6 under root 5 iota, they also get cancelled and we get 0 equals 0. That proves that this is a root of this equation. That is what we had to do in this case. Okay. Now, just a tip. You can, once you do this, evaluate the square and you evaluate the cube, you can actually verify this on your calculator as well. Now, let me see if I remember how to do that. I'll just do that quickly. So I'll show you how to verify your calculation for the square and the cube. Now, you will still need to show your working. You can't do it without showing working. If you do this on your calculator directly, you don't get any marks. You get 0 marks for that. Okay. But you can verify your working in that step, because otherwise, if you end up having some plus minus error somewhere and you find that out at the very end, that will waste a lot of time, right? Then you have to figure out where exactly the mistake was. So let me see if I can do that here quickly. So if I go to menu here, I have this option, complex. And then I'm just going to try this. I've not tried this before. I think it works like this, but let me see. Minus 1 plus under root of 5. Iota is this button, is on this button. See the button above 8, the one that has E and G written. On top of this button, you have iota written. Just press that button directly and you write this iota thing here. And then let me see if it works. Square of this. Yeah, that gives you the result. Minus 4 minus 2 under root 5 iota. That's the result that you get from this. Okay. So you can see your square calculation is correct here. Similarly, you can do cube here. You see you get 14 minus 2 under root 5 iota. Your cube calculation is also correct here. Okay. So before you input them there and in that equation, you could verify this on your calculator as well. Now that's just for verification, because if you don't show working, you don't get any marks for that. So you have to show working. Okay, this is just for verification. You sometimes find that helpful. Okay, now we need to find the other roots of this equation. Okay, now again, your calculator can help you out here verifying your answer. The polynomial equation function of your calculator, you have to use degree 3 here, and that will give you the other solutions. Okay, but we have to show working, so let's actually follow through that process and see how you would do that. The equation is 2x cubed plus x squared plus 6x minus 18 equals 0. That's the equation. Now, one of the solutions that they've given for this equation is x equals minus 1 plus under root 5 iota. That's one of the solutions. Now, this is an equation that has all real coefficients. If all the coefficients are real, what that means is the conjugate of this root is also going to be a solution. So minus 1 minus under root 5 iota is also a solution. So one of the other solutions is this, minus 1 minus under root 5 iota. Okay, so that's one other solution. Now, we also need to find the third solution. Now, the easiest way of doing that is using the sum of root formulas. Sum of root formulas. What do they look like? Sum of roots is given by sum of roots is given by minus b over a, right? That's the sum of roots formula that you've got. Minus b, that's b is the coefficient of this term. The second term, that's minus 1 divided by a, which is 2. This is the sum of roots for this polynomial. Now, one of the roots, so that what that means is x1 plus x2 plus x3. If x1, x2, and x3 are the three roots of this equation, their sum is supposed to be minus 1 over 2. We know two of the solutions already. They are minus 1 plus under root 5 iota. That's one solution. And then you have the other one, which is minus 1 minus under root 5 iota. And then plus x3, that equals minus 1 over 2. Under root 5 iota and under root 5 minus under root 5 iota, they get cancelled. Minus 1, that's minus 2 plus x3 equals minus 1 over 2. The third solution turns out to be 3 over 2. So these are the three solutions that you've got then. 3 over 2, minus 1 minus under root 5 iota, and minus 1 plus under root 5 iota. These are the three roots that you've got. Okay. If the roots are not real, if the coefficients of this equation are not real, then the answers are not, then the complex roots are not conjugate. Okay. And you can't do it that way then, okay? Because otherwise, you would have to do division, first of all. And in that division process, you would have iota involved. That makes it very complicated. I haven't seen any questions like that in past papers, where you have coefficients in terms of iota, and they want you to solve a cubic equation or a quadratic equation. In quadratic equation, that comes, but in cubic, etc., it does not necessarily come, okay? All right, so this is what we can do, the sum of roots formula. The other possibility is that standard method that you learn, although that's going to be longer here. You can use that as well. What's that? The other possibility is, how much space do we have? Okay. The other possibility is you say these are the two solutions that you've got. X equals minus 1 plus under root 5 iota. This is one solution. Conjugate, you've already figured out, that's the other solution, minus 1 minus under root 5 iota. If these are the two solutions, what are the factors going to be? Just like if x equals 4 is a solution of an equation, that means x minus 4 is a factor. Now, in this case, x equals 1 minus 1 plus under root 5 is under root 5 iota is a solution. We can say x plus 1 minus under root 5 iota, this is going to be one of the factors. And x plus 1 plus under root 5 iota is going to be the other factor. So you've got two factors of that polynomial, okay? Now what you do is, using these two linear factors, what you do is you find a quadratic factor. How do you do that? You multiply these two factors. That gives you x plus 1 minus under root 5 iota multiplied by x plus 1 plus under root 5 iota. Now you can do this complete multiplication like you normally do. Multiply every term of the first expression and every term of the second expression. Or it makes things simpler like this. If you say this is A, this is B, this is A, this is B, you see it's that form, A plus B into A minus B. Sorry, this is A minus B. A minus B into A plus B. You can multiply this easily like A square minus B square. Okay, and that makes it much simpler. So you get x plus 1 whole squared minus under root 5 iota whole squared. And now you simplify this further. This gives you x squared plus 2x plus 1 minus 5 iota squared, which means 5 into minus 1, which is x squared plus 2x plus 6. Right? This is the quadratic factor that you've got. Once you've got the quadratic factor, now what you do is, this original polynomial that you had, you divide that by this quadratic factor to find the other linear factor. Let's do this division process now. We need to divide 2x cubed plus x squared plus 6x minus 18 by x squared plus 2x plus 6. We need to do this division. X squared multiplied by what is going to give you 2x cubed? X. And then you have 2x. 2x into x squared, that gives you 2x cubed. And then 2x into 2x, that is 4x squared. And then 2x into 6, that is 12x. Do the subtraction. This becomes minus, minus, minus. This gets cancelled. X squared minus 4x squared, that is minus 3x squared. Minus 6x minus 18. X squared into minus 3 is going to give you this. And you give, and that gives you minus 3x squared, minus 6x, minus 18. And that gives you 0 at the end. And that's what you wanted. You've got 0 as the remainder. And that was expected because it's a factor. Okay. And now 2x minus 3 is the other factor. So how do you find the solution from that? 2x minus 3 equals 0, x equals 3 over 2. This is the real solution that we were looking for. So again, we've got those two other solutions. X equals minus 1 minus under root 5 iota, and x equals 3 over 2. That's the final result that we get. Okay. Okay, so I hope that makes sense. Where am I getting minus 1 over 2 from? Well, remember we studied this, Faizan, when we did the crash course. We talked about this other method as well. Sum of roots minus b over a. That's the formula that you've got for this. You studied this in SAT as well. We're using that. Minus b over a. Sum of roots for any polynomial is given by minus b over a. Okay. That's where this is coming from. Okay, good. So that's how you could do it. You've got both possible methods for this. Let's move on to the next one now. This was question number 7. Okay, let me see what other questions you have from this paper. So apparently there are no other questions that you found difficult from this paper. This is the differential equation problem. You would divide that on the other side. Okay, so that can be, x can be integrated using ln rule here. The x, sorry, no, not ln rule. Let me actually do that. The first step for you, and then you can do it. Y comes to the left side, 1 over y into dy, and then 1 minus 2x squared over x dx, right? When you separate the variables, this is what you get. The integration of left side is ln y. How would you integrate the right-hand side? How do you integrate the right-hand side? It's a fraction. Does any of the fraction rules work here? None of the fraction rules work. What we can do instead is we can actually split into two parts. So the numerator splitting rule, right? That works. That's not exactly a rule, but that's a trick that we can use. What we can do is we can split it into two parts. We can say this is the same thing as saying 1 over x minus 2x squared over x. Split this fraction into two parts like this. And now, what's the integration of 1 over x? That's just ln x. And what about, sorry, that was 2x squared over x there. X and 1 power of x from the numerator gets cancelled, and we just have 2x left here. What's the integration of 2x? 2x squared over 2. And that's how you integrate the right-hand side plus c, and that's it. Okay, that's the integration. And then you just put those values of y and x, find the value of c, and then make y, write y in terms of x. Actually, we have come this far. Let's do that as well. Ln y equals ln x minus x squared plus c. Now put those values of x and y. X equals 1, y equals 1. What does that give us? That gives us ln 1 equals ln 1 minus 1 squared plus c. 0 equals 0 minus 1 plus c. The value of c turns out to be 1. And this equation, therefore, is ln y equals ln of x minus x squared plus 1. And now what you want to do is you want to make y the subject. You want to write this as y in terms of x. Okay, so y needs to be made the subject. Now, do not directly make it e raised to power ln x minus x squared plus 1. That's not the preferred way of writing this. You should avoid having ln as a power of e, because this is not simplified form. What you should do in such problems is you should first write the ln terms as a single term. Okay, so you've got two terms that have ln in them. So this is not a preferred way, although this is correct. Sometimes they would reduce, they would deduct 1 mark for this because this is not simplified enough. What you would do in such problems would be, you would say, you can write this as ln y minus ln x. Take the ln terms to one side. On the other side, you have 1 minus x squared. Now you write this as ln of y over x. That equals 1 minus x squared. So you take all ln terms to one side. Okay. And then write them as a single log term, ln of y over x. Now, base of ln is e, that goes to the other side, becomes the base of 1 minus x squared. So you get y over x equals e raised to power 1 minus x squared. And then you finally get y equal to x e raised to power 1 minus x squared. That is what they would ideally want you to do. Okay, that's the final result that we get from this. Y equals x e raised to power 1 minus x squared. If you're getting ln as the power of e, just know that is generally not simplified form. So the way to do this properly is that you take all the log terms, the ln terms to one side, use the multiplication law or the division law to make it a single ln term, and then you get rid of that ln like this. Okay, by taking e to the other side and making it the base of whatever you have on the other side. All right, so that's the solution of this differential equation. That was, again, a fairly straightforward problem. Then you have partial fractions, binomial. Then you have this integration. You have to use integration by parts here. And the second part, I think, for finding the area. And the first part is just differentiation. Use the product rule here. Again, not that difficult. Question number 11, these lines intersect. Find the value of A and the position vector of the point of intersection. Now they're saying, given that the two lines intersect, what that means is when you equate the two equations, you would get 3 equations from that, right? One for x components, one for y components, one for z components. You would find the values of lambda and mu from 2 equations, put that in the third equation, and that will give you the value of A. And then you can find the position vector of the point of intersection as well. Again, it does not look that difficult, and I think none of you have asked about it as well. Yeah, okay. So first part is pretty straightforward. Given instead that the angle is this, find the 2 possible values of A. Okay, do you want me to do this? Should I do this last question, or should we move on to the next paper? Do you guys want me to do this last question? Okay, let me do this very quickly. Okay, I'll do this very quickly and then we'll move on to the next paper. 2 lines have these equations. Given that the lines intersect. Okay, so what I'll do is I'll do it very quickly, okay? Given that the 2 lines intersect, find the value of A and the position vector of the point of intersection. Now, how do you start? First of all, write this in column vector form. That makes things easier to understand. The first equation is R equals 1, 2, 1 plus lambda into A 2 minus 1. That's the first equation. And then the second equation is two 1 minus 1 plus mu into 2 minus 1 1. You have to equate them, right? Because you're looking for the point of intersection. Just equate these 2 equations. How do you do that? Simplify them. It becomes 1 plus lambda A. 2 plus 2 lambda. So I have to write it like this instead. 1 plus a lambda. And then 1 minus lambda. This should equal 2 plus 2 mu, 1 minus mu, and minus 1 plus mu. You get 3 equations from that. This is equation number 1, equation number 2, equation number 3. Solve any 2 of them simultaneously. You would get the values of lambda and mu from them in terms of a and only a, in fact. There's only one unknown there. Yeah, in terms of a, you get lambda and mu. Let's do that. 1 plus a lambda equals 2 plus 2 mu. And then 2 plus 2 lambda equals 1 minus mu. All right. Okay, now let's make one of the variables the subject here. I think it's going to be easier if we make mu the subject from the second equation. That will give us mu equal to 1 minus 2, which is minus 1 minus 2 lambda. Put this in the first equation. And that gives us 1 plus a lambda equals 2 plus 2 into minus 1 minus 2 lambda. Minus 1 minus 2 lambda, 2 plus 2 into this. Yeah, that looks okay. 1 plus a lambda equals 2 minus 2 minus 4 lambda. And we have minus 4 lambda. Let's take lambda terms to the other side. A lambda plus 4 lambda. Bring 1 here. That becomes minus 1. We want to find the value of lambda, right? So you can take lambda common. Make that the subject. So lambda into a plus 4, that equals minus 1. And the value of lambda turns out to be minus 1 over a plus 4. Put that in the other equation. We'll get the corresponding value for mu. Mu equals minus 1 minus 2 into minus 1 over a plus 4. Let's see what this turns out to be. Minus 1 plus 2 over a plus 4. You can take LCM if you want, or just leave it like this, and that's okay. These are the values that we're getting for lambda and mu. All right. Okay. Now, if the lines intersect, what that means is the values of lambda and mu that you found here, they should satisfy the third equation as well, because only then the lines intersect, otherwise they would be skew. They have given that the lines intersect, so the third equation should also satisfy these values. Let's put these values in that third equation. What's that third equation? 1 minus lambda equals minus 1 plus mu. This is your third equation. Let's put this here. 1 minus 1 over a plus 4, that equals minus 1 plus 2 over a plus 4. I've just input the values of lambda and mu here. Now let's simplify this. We get 1 plus 1 over a plus 4, that equals minus 2 plus 2 over a plus 4. What I'm going to do is I'm just going to multiply the whole equation by a plus 4. To get rid of the fraction, I can multiply the whole equation by a plus 4, right? The LCM that we've got here. If you multiply the whole equation by a plus 4, that gives me a plus 4 instead of this, plus 1 on the left side. On the right side, I have minus 2 into a plus 4 plus 2. And now simplify everything, and that gives us a plus 5 equal to minus 2a minus 8 plus 2. 3a equals minus 6 minus 5, right? Is that correct? Any careless error you can spot here? I think it's okay. 3a equals minus 11, and the value of a that I'm getting is minus 11 over 3. Okay, does that look okay? Minus 11 over 3, that's the value of a that we're getting. Okay, now it also asks us to find the position vector of the point of intersection. How do you find the position vector of the point of intersection? Now that we know the value for a, We can find lambda and mu now as well. Lambda is this and mu is this. Find any of them and put that value of lambda or mu in either this equation or this equation. You will get the position vector of the point of intersection. All right, so that's what they want you to do now. So what do we get from this? We get lambda equal to -1 over a plus 4. A is -11 over 3 plus 4. Let's see what the value of lambda turns out to be. -1 over -11 over 3 plus 4. And that's giving me -3. So the lambda value turns out to be -3. Okay. If lambda is -3, we can input that either here or here. It's easier to input in the second equation because that does not have any a in it. So let's do that. For that, we needed actually mu. We don't have mu here. Okay, let's put this in the first one. If I put this in the first one, that gives me r equals 1 plus a lambda, 1 plus a, which is -11 over 3 into lambda, 2 plus 2 lambda, 2 plus 2 into -3, and then 1 minus lambda, that's 1 minus -3. The point of intersection turns out to be 1 plus 11, which is 12, 2 minus 6, which is -4, 1 plus 3, that is 4. This is the point of intersection that we were looking for. So there were two things that we wanted to find. One was the value of A, and the other was the point of intersection, the position vector of the point of intersection. These are the two things that we wanted. Okay, let's move on to the next part. Now it says given instead. Given instead means whatever was given in the first part, that is no longer relevant. The first part is not relevant anymore. Okay. Given instead that the acute angle between the directions of the two lines is cos inverse of 1 over 6, find the two possible values of A. Okay, now the two lines look like this. They're saying the acute angle between them, let's call this theta. Theta equals cos inverse of 1 over 6. What that means is cos of theta equals 1 over 6, right? If theta equals cos inverse of 1 over 6, then cos theta equals 1 over 6. And now we use the angle formula. What's the angle formula? A dot B divided by modulus of A into modulus of B. Cos theta equals this thing. Acute angle between the direction of the two lines. That is this. Okay. Now, what are the directions of the two lines? A2 minus 1. Okay. Let's call the first vector A2 minus 1. That's the vector A basically. And then the second direction vector is 2 minus 1 and 1. Let's find their dot product first of all. 2 minus 1 and 1. What's their dot product? A into 2, that's 2A. 2 into minus 1, that's -2. Minus 1 into 1, that's -1. The dot product is 2A minus 3. What about the magnitudes? Magnitude of the first vector, A2 minus 1. What's the magnitude of this vector? Square root of A squared plus 2 squared plus 1 squared, and that gives us A squared plus 5. That's the magnitude of this first vector. And then we find the magnitude of the other vector. The other vector is 2 minus 1 and 1. That is 2 squared plus 1 squared plus 1 squared. And that turns out to be under root 6. So we've got everything that we need to input in that formula now. We know cos theta is supposed to be A dot B over modulus of A into modulus of B. we can say cos theta equals A dot B, the dot product, that's 2A minus 3, divided by their magnitudes, product of their magnitudes, that is square root of A square plus 5 and square root of 6. And now we know cos theta is 1 over 6. So we get 1 over 6 equal to this thing. Okay, I can write it like this if I want. 2A minus 3, this is square root of something, same powers. We can multiply the bases, and that is going to give me 6A squared plus 30 whole square root. And now we need to solve this equation. How do we solve this equation? We can start by maybe cross multiplying. If we cross multiply, that gives us 6A plus 30, 6A squared plus 30. On the other side, we've got 12A minus 18. Now to get rid of the square root, we can square both sides. When we do that, we get 6A squared plus 30 equals 12A minus 18 whole squared, right? This is A minus B whole squared. Don't just put that power 2 on the individual terms. It has to be whole square, okay? Now let's simplify this. It becomes 6A squared plus 30 equals 12A whole squared. What's that? That's 144A squared minus 2 into 12A into 18. That's 432 plus 18 squared, that is 324. Okay, now let's simplify everything. 144 minus 6, that's 138A squared minus 432 times A plus 294 equals 0. Okay, now you can simplify this if you want, but it's not needed as such. You can just put everything in the quadratic formula directly and then write down the answers directly. Minus into minus 432 plus minus square root of minus 432 whole squared minus 4 into 138 into 294 whole divided by 2 into 138. Okay, so this is what we are getting. Okay, so what do we do now? By the way, we haven't used this yet, acute angle. So we might need to take care if we have a problem there. Let me see what we get from this. A equals what? Menu equation polynomial degree 2, 138 minus 432 and 294, and that is giving me one possible value, that's 49 over 23, and another possible value which is 1. And it looks like there's a problem because 2 into 1, that's going to give me something negative. Cos cannot be negative if the theta is acute. The other value of A that I'm getting is 49 over 23. What's that? That is going to give me something positive. So one value is giving me the correct thing. The other value is not giving me acute angle. If the angle is not acute, what's the other possibility? Where else you would get 1 over 6? It would be cos is positive. It's either here or here. If it's negative, that's also going to give you 1 over 6. We needed the two possible values of A. Okay, I'm just thinking, what's the use of this acute angle? Because this is 2A minus 3, and that's a positive dot product. But it becomes negative if A is 1. If A is 1, this would be negative. And then we could just reverse that. That makes sense. And give an obtuse angle. Okay, all right. So that makes sense. That's okay. So it turns out that's not going to cause a problem here. Okay, so these are the two values of A that that we get 49/23 and A equals 1. And that's all right. So basically, I was just thinking that since the angle is acute, the dot product has to be positive here, but apparently that does not make a difference because what we have done here is theta equals cos inverse of 1/6. That is supposed to be a positive value, but when we use cos theta equal to 1/6, now cos theta can be equal to 1/6 in the first quadrant as well, but also in the fourth quadrant. So even if theta was negative in this case, that would also work. But okay, so forget about that. There was some detail that I was thinking about here, but it turns out it does not cause any problems here in this case. Okay, so these are the values of A that I'm getting. A is 49/23 and the other value of A is 1. That is all that we were looking for. Okay, all right, good. So that's the last question from this paper that we wanted to discuss. Now let's move on to the other one. That's part B. Okay, fairly easy paper overall. There was not much complexity. Has anyone seen the threshold for this paper? Was that really high? It looks like it should be high for this paper, but it's a 2020 paper, so maybe not because it was that 𝗣𝗽𝗀𝗿. Okay, 2020 paper 3.2. Okay, so that's the next paper that we want to do now. Difficult question from the second paper. Okay, so let me know the problems that you have from this paper now. Please make sure to respond to the poll if you haven't already. Look at the poll posted in the WhatsApp group. Let me know the questions that you find difficult from this paper, so we can have a look at those specific questions from this paper. This is November 2020 paper 3.2 now. This is the next paper that we are starting. Okay, so from this paper, which questions are you asking about? Questions 3, 5, and 10. Okay, so these are three main questions that we're asking about. I'll have a look at the rest of the paper as well and see if there are any other questions that look complicated. So questions 3, 5, and 10, these are the three questions in particular that you're asking about. Okay, so let's start with this then. November 2020, paper 3, variant 2. Let's begin. Okay, so it says solve this equation, fairly straightforward, the first question, and then you have this binomial expansion, again, quite straightforward. State the set of values of x where this expansion is valid. This is already in standard form, 1 plus 6x, so you'll just say 6x is between -1 and 1. That means x is going to be between -1/6 and +1/6. Okay, we've done this before as well. It should make sense. Linear law. Did you ask about this linear law question? Why? Okay. Is that a very straightforward concept? Okay. So for some reason, you guys are asking about question number 3 from this paper. Let's have a look at this. Okay, so the variables x and y satisfy this relation. 2 raised to power y equals 3 raised to power 1 minus 2x. It says by taking logarithms, show that the graph of y against x is a straight line. Y against x. That means, what's the straight line form? Y equals mx plus c. And in this case, they want y to be y. And they want x to be x. There's nothing that has changed. This is the form that you wanted to convert to. Okay, y equals mx plus c. And we also need to state the exact value of the gradient of the sine. So let's convert it to that form. How do you do that? You've got 2 raised to the power of y equal to 3 raised to the power of 1 minus 2x. How do we start? Take log on both sides, take ln on both sides. It becomes ln of 2 raised to the power of y. That equals ln of 3 raised to the power of 1 minus 2x. Use the power law to bring the power down. It becomes y ln 2 equals 1 minus 2x into ln 3. Do not forget the brackets here. 1 minus 2x, this whole thing is multiplying by ln 3. Okay. Now let's simplify this. It becomes y into ln of 2 equals ln 3 minus 2x into ln 3. Now let's rearrange this a little. On the right side, I could say this is ln, or in fact, minus 2 ln 3. I'm writing 2 and ln 3 together because they're both constants, multiplied by x plus ln 3. And now this ln 2 from the left side, we can divide that to the right side because we want to convert it to this form, right? We need to make y the subject. So I'm dividing ln 2 on the other side. It becomes minus 2 ln 3 over ln 2 plus ln 3 over ln 2. And now you can see this whole thing, this is the gradient. If you compare it with that standard form now, y equals mx plus c. The gradient is going to be this whole thing. That's what they were looking for. The gradient of the sine, the exact value of that is minus 2 ln 3 divided by ln 2. Now they wanted an exact value, so do not convert it to decimals, leave it as it is. All right, that's first part. Okay, so you're saying for the previous paper, the threshold was 62. That's pretty high for a paper 3. For an A, 62. So yeah, that shows the paper was quite straightforward. Okay, now find the exact value, exact x coordinate of the point of intersection of this line with y equals 3x. Give your answer in the form ln A over ln B. We need to find the point of intersection of this line. It's a straight line, right? With the line y equals 3x. Now one line is y equals minus 2 ln 3 divided by ln 2 into x plus ln 3 over ln 2. What we want to do is, we want to solve this equation simultaneously with y equals 3x. So what we can do is, we can put in this equation in place of y, 3x. Replace y with 3x. What does that give you? 3x equals this. And now this is the equation that we want to solve. But the answer that we want at the end has to be exact. Okay, so we can't use decimals here. Now, how can we do that? How do we make it simple enough? Okay, to simplify things, I think we can start by doing something like this first. Multiply the whole equation by ln 2, okay, to get rid of the fraction. If I multiply the whole equation by ln 2, that gives me 3 ln 2 into x. On the other side, I have minus 2 ln 3 into x plus ln 3, right? When I multiply the whole equation by ln 2, this is what I end up getting. All right. Now, we need to make x the subject. So bring this term to the left side. It becomes 3 ln 2 into x plus 2 ln 3 into x equals ln 3. And now take x common from here. That leaves you with 3 ln 2 plus 2 ln 3 equals ln 3. And now divide this on the other side. And you would get ln 3 divided by 3 ln 2 plus 2 ln 3. Now that is supposed to be defined. That's supposed to be the answer. Okay. However, they want you to convert this thing to this form. There's going to be 1 mark for this conversion. ln A over ln B, where A and B are both integers. Now in the numerator, we already have ln of something, and that something is an integer. So numerator is sorted out. What about the denominator? We need to make this a single ln term. How can we do that? We can use multiplication law, but for using the multiplication law, we need to get rid of this 3 and this 2. How can we do that? We can take them to the powers. ln 3 over ln of 2 cubed plus ln of 3 squared. And that is going to become ln of 3 over ln of, or let me write it, yeah, 2 cubed multiplied by 3 squared, right? Addition outside, multiplication inside. We're using the multiplication law of logarithms. And now this becomes ln 3 divided by ln of 8 into 9, right? That is 72. ln of 3 over ln of 72, that is the value of x that we were looking for. That's what we wanted, okay? That's the second part of this question. All right, I hope that makes sense. That's question number 3, part B. That was quite some working for 2 marks. So that's what we get. Now let's move on. Question number 4. Okay, not many of you have asked about this. It should be fairly straightforward. You want to convert it to a quadratic form, right? Apply the compound angle identity for this. Write cot as 1 over tan, and then just simplify everything. You should get this thing. Then you have to solve that. Yeah, that's not very difficult. You can do that. Question number 5. Okay, so this is the next question that you're asking about. Question number 5 from this paper. Let's try this. It says the diagram shows the curve with parametric equations. X equals tan theta and y equals cos squared theta, where theta is between minus pi over 2 and plus pi over 2. Show that the gradient of the curve, okay, gradient of the curve at the point with parameter theta is this. How do you find gradient of a curve? You find gradient of a curve by differentiation. So what they're actually asking you for is the derivative of this curve. That's all that they're asking for. They just changed the wording of the question, but they're just asking for the derivative. They're asking you to find dy over dx in terms of theta, right? That's all that they want. So let's find dy over dx, because that is what represents the gradient of the curve. Faizan, let me come back to that. Let me come back to that in a moment. Gradient of the curve at the point theta with parameter theta, that's what we want to find out. Okay, so how do you do that? You've got x equals tan theta, and you have y equals cos square theta. Cos square theta can be written as cos theta whole squared. Now you find dx over d theta. What's the derivative of tan? It's secant square, so it becomes secant square theta. Dy over d theta, remember your variable is theta, so you would have theta in the denominator like this. Dx over d theta, dy over d theta. What's the derivative of cos square theta? It's the power function. You multiply, use the power rule of differentiation, multiply by the power, subtract 1 from the power, it becomes cos theta, multiply by the derivative of the base of the power. What's the derivative of cos? It's minus sine. So you've got minus sine theta here. And now you find dy over dx. This simplifies to minus 2 sine theta into cos of theta. How do you find dy over dx now? Dy over dx equals dy over d theta into d theta over dx. Okay. Now, what's dy over d theta? That is minus 2 sine theta into cos of theta into d theta over dx. That is 1 over secant square theta. Now you wanted to prove that the derivative is this, that they only have sine and cos in that form. What is secant? Secant is reciprocal of cos. So we can write this as minus 2 sine theta into cos theta into cos square theta. right? Because secant 1 over secant square is the same thing as cos square. And now this simplifies to minus 2 sine theta into cos cube theta. This is dy over dx. That is what we were looking for. And that represents the gradient of the curve, right? Okay, with parameter theta, all that means is you have to write down your answer in terms of theta. If they had given you a specific value of theta, you would put that value of theta there in the dy over dx thing. But in this case, you just leave this in terms of theta, and that's it. All right. Now, let's look at the next part. In part B, it says, the gradient of the curve has its maximum value at the point P. Now, this is a very important type of question because it's slightly confusing, and the marking schemes for questions like these, they're also very confusing. They use second derivative and third derivative, and they are very confusing. So let me explain what that means. What we have found in the first part is that dy over dx is minus 2 sine theta into cos cube theta. Yeah, that's the derivative that we have found. Now, what they're saying is the gradient of the curve has its maximum value at the point P. Where is point P on the graph? This is point P. Is that the maximum point of the graph? Well, it's not. Maximum point is this one. This is the point where the gradient is maximum. That means where the tangent to the curve has the highest gradient. It's the steepest part of this curve. And that's what it means. How do you find this point? This is the point where the gradient of the curve is maximum. What represents gradient of a curve? Dy over dx, that is basically the gradient of a curve. This represents the gradient of a function, dy over dx. What you would do is, you would say, let's call this a new function, minus 2 sine theta into cos cube theta. You would say this is your gradient function, right? Dy over dx, for this represents the gradient of that original curve. So we would say g is the gradient function. And g is the gradient function. It represents the gradient. And now what we want to do is, we want to find the maximum value of the gradient. We want to find the x coordinate of that. X coordinate of the maximum point of the gradient. How do you find maximum point of a function? Now, we are treating this as a new function, remember? This is the gradient function. Let me write that here as well. This is what represents the gradient function. All we need to do is find the x coordinate of the maximum point of this function. How do you do that? Find the derivative of this function, put that equal to 0. Find the derivative of this gradient function. What's that? It's a product. Minus 2 outside remains as it is. You apply the product rule here. You say this is u, this is v. So it's uv dash plus vu dash. U as it is, that means sine theta as it is, into derivative of cos cube theta. That's a power function. Multiply by the power, subtract 1 from the power, multiply by the derivative of the base. What's the derivative of cos? It's minus sine theta. Okay. Plus, make sure that you're using your brackets correctly. This minus 2 is outside, multiplying with the whole thing. Now vu dash, v as it is. What's v? V is cos cube theta into derivative of sine, which is cos theta. This is the derivative of the gradient. Since you're looking for the maximum point of the gradient function, you put this equal to 0. Put the derivative equal to 0. That's how you find the turning point. That's how you find the maximum point or the minimum point. Put this equal to 0. What does that give you? Minus and minus, that is plus. 2 into 3, that is 6. 6 sine square theta into cos square theta plus cos raised to power 4 theta. This, there's a 2 there as well. Minus 2 into that thing, that will be minus 2 cos raised to power 4 theta. Right? 6 sine square theta cos square theta minus 2 cos raised to power 4 theta. Yeah, that looks okay. Now you need to solve this equation. How do you do that? It's a simple trigonometry equation now. Do we know the interval for theta? Yeah. Theta is between minus pi over 2 to plus pi over 2. Okay, let's solve this equation. How can we solve this? We can take 2 cos square theta common. That leaves us with 3 sine square theta minus cos square theta inside, that equals 0, which means either cos square theta equals 0, or you can say 2 cos square theta equals 0, or 3 sine square theta minus cos square theta equals 0. Now, this can be written as 3 sine square theta minus 1 minus sine square theta equals 0. And that gives you 4 sine square theta minus 1 equals 0. Sine square theta equals 1 over 4. Now you take square root, but remember, whenever you take square roots, you have to put plus minus. Okay, you have to put plus minus. So this becomes sine theta equals plus minus 1 over 2. Okay. And the first equation, what does that become? Cos square theta equals 0, and then cos theta equals 0. Find the basic angle from this first equation, or just think of the graph of cos. Where is cos 0 on the graph? Cos is 0 at pi over 2, at 3 pi over 2, and minus pi over 2 before that, because we have negative interval as well. Now the interval is from minus pi over 2 to plus pi over 2. Minus pi over 2 is not included. Pi over 2 is also not included. That means we don't have any answer from this first equation inside our interval. This is no solution in the given interval. So we don't get anything from here. Okay. What about the second one now? This is sine theta equals plus minus 1 over 2. We find the basic angle from this. Sine alpha equals 1 over 2. What's the basic angle? Sine inverse of 1 over 2. Do we have to have this in radians? Sine inverse of 0.5, that is pi over 6. Okay, so the value of theta, value of alpha, the basic angle that I'm getting from this is pi over 6. So alpha is pi over 6. Now, which quadrant can it be in? Now, this says it can be any quadrant. Plus minus, right? Plus minus means it could be any quadrant. However, the interval that we're given, that is from minus pi over 2 to plus pi over 2. What does that mean? This is minus pi over 2. This is plus pi over 2. This is the interval. So these are not possible. Then you can either have a value in the first quadrant or in this quadrant. That means theta can either be pi over 6 or it can be minus pi over 6. These are two possible values of theta that we are getting. Two possible values of theta. Okay. Now, the question says find the exact value of x coordinate of P. The final answer that we want has to be only one answer, right? Because it says exact value. There's no plural here. You need to have one answer. Now you have two values of theta. Let's see what x is. X is equal to tan theta. Okay, x is tan theta. Let's put these values in tan theta. X equals tan theta. We want to find the x coordinate, right? Let's put the negative value, tan of pi over 6, sorry, positive value and the negative value, x equals tan of minus pi over 6. Tan of pi over 6, what does that give us? tan of pi over 6. That is giving me under root 3 over 3. And then if I do tan of minus pi over 6, that will give me negative under root 3 over 3. These are the two possible values of x that I'm getting this. Okay. But look at the graph now. Where is p? P is on the left side. On the left side, the x coordinate of p has to be negative. It can't be positive. It's a negative value. So what we do because of that is we say only this answer is possible because the other point cannot be p. This is the maximum value of the point where the gradient has its maximum value, not this one. This is the x coordinate of p. This value would actually give you this point on the other side. That's here. At this point, the gradient would be minimum actually. It's negative, right? The gradient is negative. That's a minimum value. Since you put the derivative equal to 0, this other point is giving you the minimum value, but that's not what we wanted. So we can see from the graph that the x coordinate of p was supposed to be negative. So we use the negative x coordinate value here. It's minus under root 3 over 3. And that's your final answer. Is that okay? Make sense? That was question number 5. Yeah. Okay. Now, to answer your question, you were saying, what if you have ln of 2 into ln of 3? How can you simplify this thing? Well, you can't do anything with this. No, none of the log rules apply here. For applying the log rule, you need to have multiplication inside or division inside or addition or subtraction outside. This is multiplication outside. The log rules do not work here. We can't simplify this further. We can just evaluate it on our calculator and write down the values if we want, but it cannot be simplified in exact form. That is not possible. Okay. All right. Now let's move on to the next question. You have to divide this, and then you have to sketch an Eigen diagram representing those points. But considering the arguments, you need to show this. 7 plus iota, 1 minus iota. Okay, now I'm going to skip the first two parts. I think you're asking about the last part here, right? So let's just focus on the last part. Now for that, we actually need to know the first part's answer. Let me see what that is. So you'll do this first part, multiply and divide by the conjugate. And what does that simplify to? What do you get from the first part? Three plus 4 iota. U equals 3 plus 4 iota. That's the answer to the first part. I'm assuming you can do that. Second part is simply sketching that Eigen diagram and representing those points. Really straightforward. Now it says, by considering the arguments of 7 plus iota and 1 minus iota, show that this thing is true. Now, this is something that whenever you see this, it should remind tan inverse of something plus plus or minus tan inverse of another thing. When you have an equation like this, it should remind you of those rules for complex numbers, the properties of complex numbers, where you study that if two complex numbers are multiplied, their moduli are multiplied and their arguments are added. And if two complex numbers are divided, their moduli are divided and their complex numbers are subtracted. Their arguments are subtracted. Okay, we have to use that here. Now, let me explain how. So one number that you have is u, which is 3 plus 4 iota. Is that relevant here? Yeah, we've got 4 over 3 here. Okay, so u is 3 plus 4 iota. And another number is 7 plus iota, and another number is 1 minus iota. Can we find their arguments? U is in the first quadrant. So whatever is the basic angle, the argument is going to be the same as well. So the argument of u is going to be tan inverse of 4/3. Now, they have used exact forms here. Don't write decimals for the because of that, okay? Leave it in this form. Argument of u is basically this, okay? What's 7 plus iota? This is also in the first quadrant. Again, whatever is the basic angle, that will be the same as the argument. So argument of 7 plus iota, what should that be? Tan inverse of the imaginary part, which is 1, over the real part, which is 7. This is tan inverse of 1/7. You see that here as well. 1 minus iota. Which quadrant is this in? 1 real part is positive, imaginary part is negative. That means it's on the right side. It's here. On the right side below in the fourth quadrant, this angle is going to be here. Now for this, what we do is we first find the basic angle. We say tan alpha equals 1/1, alpha equals pi/4. This is the basic angle. Now, since we are in the fourth quadrant, that is here, what's the argument going to be? It's on the negative side. The argument of 1 minus iota is minus pi/4, right? Because it's in the fourth quadrant. We go from the negative direction here. That's the argument of 1 minus iota. We've got these three things now. Now notice what was the connection between these complex numbers. In the first part, u is equal to 7 plus iota over 1 minus iota. That's what we had in the first part. U is basically equal to 7 plus iota divided by 1 minus iota. We have two complex numbers. U is basically the quotient of 7 plus iota and 1 minus iota. What that means is these are two complex numbers divided. What does that mean for their arguments? Argument of u is going to be argument of 7 plus iota minus argument of 1 minus iota. This is a property that you need to know about, right? Argument of u over v, or let's not confuse u and v here. Let's use some other letters. Z1 over Z2. If two complex numbers are divided, their arguments are subtracted. Right? That's the property that you need to know about. Now we just input their arguments here now. Argument of u, what's that? Tan inverse of 4/3. That equals argument of 7 plus iota. That is tan inverse of 1/7. Minus argument of 1 minus iota. That is minus pi/4. And you get tan inverse of 4/3. That equals tan inverse of 1/7 plus pi/4. And that is what we had to do here. We have proved that equation. That's all that we wanted to do here. Okay. If the argument is in the second or third quadrants, for the second quadrant, if it was here, you would find the basic angle, and you find this angle then, that will be pi minus alpha, whatever the basic angle is. In the second quadrant, that's what you do. If it's in the third quadrant, you find the basic angle again, but here you go in the negative direction, and that will be minus pi plus alpha, the argument. Okay. In the first and second quadrants, arguments are supposed to be positive. In the third and fourth quadrants, we write arguments as negative numbers because the convention that Cambridge uses is that they say that the arguments have to be between minus pi and pi. Okay. There's another convention of writing this from 0 to 2 pi as well, but Cambridge generally prefers that you write arguments within this interval from minus pi to pi. So that means in the first and second quadrants, you would write positive arguments. In the third and fourth quadrants, you would write negative arguments. Okay. All right. So that's what we get. That's part C of this. So this is a standard question where you have to use this property, where you have tan inverse of something in an equation like this that should quickly remind you of this property. all right, of arguments being added when complex numbers are multiplied and arguments being subtracted when complex numbers are divided. Let's move on to the next one now. Okay, this was question number 6. What's the next one that you've asked about? So after this, you've asked about question number 10. What I'll do is I'll quickly skim through the rest of the questions here as well. This is, I'll actually tell you about this, just the integration part, and then you can do it after that. It's a differential equation. How do we, in fact, first of all, let's separate the variables. Let's see what we get from that. When we separate the variables, that is going to give us 1 over cos square of 2x. On the right side, you would have 1 over e raised to the power 3t dt, right? You get 1 mark for just separating the variables generally. You have separated the variables now. Now you just need to integrate both sides, okay? The right side is both sides are actually simpler, but let me actually do the first, this right side first. You can write this as e raised to the power minus 3t. What's the integration of e raised to the power minus 3t? You'll say e raised to the power minus 3t as it is, divided by the derivative of this thing, which is minus 3. You have a plus c here on the right side. How do you integrate 1 over cos square 2x? What's the integration for this? Remember, we covered this when we do integration. It looks tricky, but it actually is not.
6 square.
Yes. Don't try to use trigonometric identities here. Don't think of this as being that even power. So if you had cos square of something, generally what we do is we use the double angle identity for that. Cos 2a equals 2 cos square a minus 1. We use this double angle identity to simplify this and then integrate it. However, this is cos square in the denominator. That is not going to work here, okay? 1 over cos square is basically secant square. So what you do is you write this as, integration of secant square 2x. And secant square, you know how to integrate directly. You know directly that the integration of secant square is tan, right? The derivative of tan is secant square, integration of secant square is tan. So this integrates to tan of 2x, but then you have to divide by the derivative of this, tan 2x over 2. That's how you would integrate this, and then you can do this further, input these values, find the value of c, and then make x the subject. The rest of it you can do. So I'm going to skip that. Then we've done these questions a lot of times already. What happens to x as t goes to infinity? They're not asking you for an exact answer. So what you can do is, you can just input a large value of t here and put this in your calculator, and that will give you the result. Or if you want an exact answer, we have basically talked about what happens in that case as well. How to think about that. I'm sure you can do it afterwards. So I'm going to skip to the next question. How would we integrate it if we had cos square x in the numerator? Well, that's a standard method that we need to know about using trigonometry. Whenever you have even powers of cos square, sine square, and tan square, you use trigonometric identities. In particular, for sine and cos, we use the double angle identity for cos 2a identity. That is what is used here. I'll just show that to you quickly. Integrating even powers of sines, cos square you asked. You would use this identity. Cos 2a equals 2 cos square a minus 1. Make cos square a the subject here. It becomes this. Use that identity to write it like this, and then you integrate the terms separately, and it becomes very simple like this, right? So even powers of sine and cos are integrated in a very similar way. You need to remember this method, okay? They expect you to be able to do it. All right, let's go back
Sir,
there.
do we need to know about odd powers?
Yes, you need to know about sine cube, cos cube, and tan cube. These 3 powers, power 3 just, you need to know about how to integrate this. This is done using substitution. For this, you use u equals cos theta. For this, you use u equals sine theta. And for this, you use u equals tan theta. These are the substitutions that we use for them. for this, you would break it down into two parts, sine square theta into sine theta, and then write this as 1 minus cos square theta into sine theta. Then use this substitution. Similarly, this you break down into two parts, cos square into cos, and then use this substitution. All right, and this you also, this you can do directly as well. But then you have to use the identity for tan. Okay, so these are standard methods that you need to know about. All right, so this is the only substitution that you should remember how to do. Otherwise, they will always give you the substitution in the question if they expect you to do that. All right. Okay, so question number 7, you can do the rest of it. If this is a vectors question, AB equals 2 times CD. Okay, an important point to remember here, when it says AB equals 2 times CD, they're not talking about vectors here. If they were talking about vectors, they would have arrow signs here. This actually means magnitude of AB, that equals 2 into magnitude of CD. So if you don't have an arrow sign above, that means length of AB and length of CD. It's not a vector, okay? Keep that in mind. So you can do that, find the angle between these two directions. Okay, you can do that as well. Show that the lines do not intersect. They are skew lines. That's a standard process. You can do that. You see, vectors questions often tend to be very straightforward. Or if they're not straightforward, there'll be one part that you have to really think about, but the rest of it is going to be standard methods. So you have to make sure that you remember the 3-4 standard methods, the major methods that you have in vectors: finding points of intersection, proving that two lines intersect or are skew, finding angle between two vectors, and finding perpendicular distance between a point and line, and also finding the foot of the perpendicular. These are 4-5 standard methods that you need to know about. There are mainly 3 methods, but then there are branches of them. If you know them, you can do most vectors questions. There's not much variation that comes in vectors. Okay, so you need to remember the steps very well that you have to follow in those methods. Okay, all right, let's move on to the next one. This was a very easy one. We have partial fractions and then integration. This will be bx plus c, and then, okay, can somebody tell me the partial fractions that you get from question number 9, part A? Okay, so the partial fractions that you would get here, they are going to be (3 over 3x plus 2). B is -1, C is 3. Minus x plus 3 over x squared plus 4. Okay, how do you integrate this now? How do you integrate 3 over 3x plus 4? Sorry, 3x plus 2. And minus x plus 3 divided by x squared plus 4. Limits are from 0 to 2. How do you integrate these fractions? The first one can be integrated using the ln rule, right? Derivative of denominator is 3. It's exactly that form. This just becomes ln of 3x plus 2. What about this? How do you integrate this now? Does the ln rule work here? ln rule does not work. It's not tan inverse form. You want a constant in the numerator for tan inverse. It's not partial fractions. You can't factorize the denominator. If it was x squared minus 4, you could factorize that, right? This can't be factorized either. You have to break the numerator, yes. You have to break the numerator so that it can be written as minus x over x squared plus 4 and 3 over x squared plus 4. And now you can integrate each of them separately. You would say this is ln of 3x plus 2 plus, what about this now? You want 2x in the numerator. You can write minus outside. So I'm going to write this minus outside. Inside now, I've got x over x squared plus 4. I want 2 in the numerator. I can put 2 here. To balance that, put 1 over 2 outside. Now this is the ln form. You can integrate this now. Numerator is the derivative of the denominator. What about this is tan inverse form, right? 3 outside, inside you're left with 1 over x squared plus 2 squared. And then you can integrate each of them. This becomes ln of 3x plus 2 minus 1 over 2 into ln of x squared plus 4 plus 3 as it is. Integration of this. This is a. What's the integration? 1 over a, that's 1 over 2 into tan inverse of x over a, x over 2. That's the integration that you get. Now you input the limits. Limits are from 0 to 2. You can do it after this, right? You'll input the limits, simplify everything. You want an exact answer at the end. So you have to show complete working. Do not just do the whole thing on your calculator and write down the answer. That's not acceptable. You have to write exact. You have to find an exact answer. Showing all working is important for that. Okay, you can do that. And at the end, make sure that you write a single ln term. If you have multiple ln terms, combine them to form a single ln term. Otherwise, you will lose 1 mark generally. Okay, make it a single ln term at the end. So do it after this. I'm sure you can figure this out. Okay, now this is the question that some of you are asking about next. Okay. Question number 10. Let's try this one. Now it says the diagram shows the curve y equals under root x into cos of x. For x between 0 and 3 pi over 2. And its minimum point m. Okay, so you've got the curve. Interval is from 0 to 3 pi over 2. Minimum point is m. You can see that in the diagram as well. X is a. M is when x is a. Show that a satisfies this equation. Tan a equals 1 over 2a. At a, you've got the turning point. How do you find turning point of a function? You find the derivative, put that equal to 0. So find the derivative of this function. You can write this function as y equals x raised to the power 1 over 2 into cos of x. Now, when you differentiate it, you have to use the product rule. X raised to the power 1 over 2 as it is. Derivative of cos is minus sine plus cos x as it is into derivative of x raised to the power 1 over 2, which is 1 over 2 into x raised to the power minus 1 over 2. Put this equal to 0. And you know, when the derivative is 0, the value of x is supposed to be a. So you put dy over dx equal to 0. So when you say when x equals a, dy over dx is equal to 0. And you get an equation like this. I'm not sure why they've given such little space for this. Okay, so this is what we get. We say 0 equals minus x raised to the power 1 over 2 into sine of x plus, or in fact, in place of x, we've already input a, so it becomes minus a raised to the power 1 over 2 into sine of a plus 1 over 2. I can write this x in the denominator with positive power, x power 1 over 2 into cos of x. Again, it should be a instead of x, to a raised to the power 1 over 2 and cos of a in the numerator. Make sense? So derivative is 0. In place of x, I've input a. Now let's simplify this. Multiply the whole equation by 2a raised to the power 1 over 2 to get rid of the fraction. Let's do that. If I multiply the whole equation by 2a raised to the power 1 over 2, it becomes minus 2a raised to the power 1 over 2 into a raised to the power 1 over 2. That becomes a sine of a plus cos of a equals 0. And that becomes 2a sine a equals cos of a. Sine over cos, sine a over cos a. That becomes 1 over 2a. And tan of a equals 1 over 2a. That's what you had to prove in the first part here. Okay, tan a equals 1 over 2a. That's the first part. Now, the second part is just using this iterative formula. You can do that, right? Make sure your calculator is in radian mode. And yeah, just use the iterative formula. Iterations should be rounded off to 4 decimal places. Final answer should be rounded off to 2 decimal places. The last decimal should be properly rounded off. Make sure that you take care of that, okay? Let's do the last part of this. It says, find the volume of the solid obtained when the region R is rotated completely about the x-axis. Give your answer in terms of pi. Now, what's the formula for volume of revolution about x-axis? Pi into integral of y squared with respect to x. Limits are values of x. X equals a to x equals b. We need to find this volume of revolution. Okay, now for that, we need the value of, or no, we don't need that. Sorry. We need the limits for this. This is 0. What about the upper limit? This is the x-intercept of the curve. Let's find that upper limit on the side here. Y equals under root x into cos of x. Put y equal to 0 to find the limits. 0 equals under root x into cos of x. That means either under root x equals 0 or cos of x equals 0. You get x equals 0. You already know that. Cos x equals 0. Now, this is the first answer that you have in the on the positive side. When is cos first equal to 0? Cos is first equal to 0 at pi over 2, right? Yeah, so this is pi over 2. Think of the graph. This is what the graph looks like, right? This is 0 when x is pi over 2. So the limit that you've got here is pi over 2. And that makes visual sense as well. If this is pi over 2, this is 3 pi over 2, that's okay. All right. So this is the limit. You've got the limits now. Now you find y square. Okay, what is y square going to be? Okay, let's evaluate y square on the side here first. Y square equals x cos square x, right? That is what y square is. We need to integrate this and input those limits. Vx is pi into integral of x into cos square x with respect to x. Limits are from 0 to pi over 2. This is what we want to evaluate. And now it's an integration problem. We have to integrate x squared into cos of x into cos square x. Now, how do you do this? It's a product. How do you integrate products? You have to use integration by parts. Okay, how do you use integration by parts here? Which two functions do you have? You have an algebraic function and a trigonometric function. Let's use ILATE, ILATE. The one on the left should be u, the one on the right should be v dash. You've got algebraic and trigonometric. Trigonometric should be taken as v dash and x should be taken as u. Okay. Now, before that, should we actually simplify this first or simplify that later? Let me think about it. If you simplify it first, using that identity, cos 2a, that is 2 cos square a minus 1, we get cos square a identical to 1 plus cos 2a over 2. If we put this first, we would have half of that, and then x into that thing, we would get rid of the square. Otherwise, we would have this thing and that integrated. Cos square x. Okay, it doesn't make much difference. You can either apply this identity first, or you can apply it after using integration by parts. It would not make any difference. Sorry, x square cos square x. No, it's x cos square x, because we have under root x here, right? Under root x squared, that is just x. That's not x squared. Okay. All right. Okay, so we can do it either way, apply integration by parts first and then that identity, or apply that identity first and then use integration by parts. Both are going to work. Okay, and there's not much difference in the number of steps you have to do. Let's use integration by parts directly. Integration of uv dash, that is given by uv minus integration of vu dash. U is x. I'm going to do that calculation here on the side. U is x. Let's write that here. U is x. V dash is cos square x. What's u dash? That is 1. What is v going to be? What's the integration of this? For integrating this, we should first write this in that form. What does that become? Using this, 1 plus cos 2x divided by 2. I'm going to break it down into two parts like this. 1 over 2 separately, and then half cos 2x over 2 separately. Half into cos 2x separately, right? It's the same thing as this. Now, let's integrate it. Integration of 1 over 2 is 1 over 2x, and integration of cos 2x is sine of 2x divided by 2. And that gives us 1 over 2x plus 1 over 4 into sine of 2x. That's the value of v that we get. Okay, so we have u, we have v, we have u dash and v dash. Now we just input this in the formula, pi into uv minus integration of vu dash, right? That's what it is. U as it is, that means x as it is, into v. What's v? V is this thing. Half x plus 1 over 4 into sine of 2x minus integration of vu dash. V as it is, which is 1 over 2x plus 1 over 4 into sine of 2x. Integration of this into u dash. What's u dash? U dash is just 1. So that's just 1 into dx. Now we need to integrate this thing. And this whole thing is, of course, multiplied by pi outside. Limits are from 0 to pi over 2. Now let's simplify this further. This gives us pi into 1 over 2x squared plus 1 over 4x into sine of 2x minus integration of half x squared over 2, right? Half remains as it is. Integration of x is x squared over 2. Let me have the negative sign as it is for now. Yeah, let me have it like this for now. And then what's the integration of this? 1 over 4 remains as it is into integration of sine. Integral of sine is minus cos. So it becomes minus cos 2x divided by 2. Okay, now let's simplify this further. It becomes 1 over 2x squared plus 1 over 4 into x into sine of 2x minus 1 over 4. Now integration is done, right? 1 minus 1 over 4x squared. And then minus, that becomes plus 1 over 8 into cos of 2x. Now, one last step before we input the limits, we can actually simplify this. Half minus 1 over 4, that's 1 over 4, right? So it becomes 1 over 4x squared plus 1 over 4x into sine of 2x plus 1 over 8 into cos of 2x. Now we input the limits. Limits are supposed to be from 0 to pi over 2. Input pi over 2 first of all. Pi remains outside as it is. Input pi over 2, that gives us 1 over 4 into pi over 2 whole squared plus 1 over 4 into pi over 2 into sine of 2 pi over 2 plus 1 over 8 into cos of 2 pi over 2. Subtract from this the case when you input x equal to 0. When you input x equal to 0, this first term becomes 0. This term also becomes 0. What are we left with? 0 plus 0 plus 1 over 8 into cos of 0. Okay, now let's simplify this further. This gives us pi into 1 over 16 pi squared. You want an exact answer, right? Yeah, in terms of pi, 1 over 16 pi squared plus 1 over 8. Okay, what's sine pi over 2? Sine 2 pi over 2, sine pi is 0. So the second term actually becomes 0. Right, this also, all of this becomes 0. Why? Because sine of pi is 0. Now, what about this term? Cos of pi. Cos of pi is minus 1. Do that on your calculator, right? Cos of pi is going to give you minus 1. And then minus this thing, 1 over 8 into cos of 0. What's cos of 0? Cos of 0 is 1. And that gives us pi into 1 over 16 pi squared minus 1 over 8, minus 1 over 8, that will be minus 1 over 4. And this ends up being 1 over 16 into pi cube minus 1 over 4 times pi. That is the result that we get from this. Okay, yeah, so that's the result that we get. That's our final answer. That's the volume of revolution of that area under the curve with the x-axis. Is that okay? No problem with this? That was November 2020 paper 3-2. Okay, so now we're done with 2023 papers, 2022 papers, 2021 papers. Some of them live, some of them recorded, and now 2020 November papers as well. June 2020, we will be doing next. In fact, I think we're done with June 2020 as well. Yeah, so we're done with all papers from 2020 to 2023, right? Except March 2021. That is what we want, that's what we still need to do. Tomorrow, we are doing March 2024. All right, so tomorrow we're doing March 2024. Make sure that you attempt that paper beforehand and help me with the calculations alongside as well, and check out for any careless errors as well, because we don't have any marking scheme to check our answers from. So you need to make sure that I'm not doing any careless errors anywhere. I tend to do them a lot. So make sure that you help me with the calculations. For that, it's important that you attempt the question beforehand, attempt the whole paper beforehand before you come to class, okay? So that's the plan for tomorrow. That's it for now. I'll see you again in the next class. Allah Hafiz. 3-2. This was 3-2. This was paper 3-2. 3-1 we did earlier. 3-3 is the same as this. Yeah, March 2024 is only one variant. That's 3-2. Yeah. We only have one variant in March. Okay. That's what we do tomorrow. All right. Allah Hafiz.